What does a quantum wave actually mean? Max Born solved the biggest puzzle in quantum mechanics. What does the wave function actually mean? Now, these are the 10 breakthroughs that led to quantum mechanics, and this is number 9, the probabilistic interpretation. By 1926, everyone agreed that Schrödinger's wave equation worked. It gave the right energy levels, predicted atomic spectra, and matched all the experimental data. But nobody knew what the wave function actually represented. Schrödinger initially thought that it was the electric charge density, like how much charge was spread out in space. But this led to contradictions with experiments involving individual particles. Born proposed something else. The wave function doesn't describe what the particle is doing, it's describing the probability of finding the particle in different states when you measure it. Specifically, psi squared gives you the probability density, the likelihood of finding a particle at a particular location or in a particular state. This interpretation solved several problems at once. When an electron goes through both slits in the double slit experiment, the wave function describes the probability of finding it at different points on the screen. The interference pattern emerges because probabilities can interfere with each other. When you measure a particle's position, you don't just observe a pre-existing location. The measurement forces the wave function to collapse to a definite state, giving you one specific outcome from the range of possibilities. Now, this probabilistic interpretation became a key component of what would later be called the Copenhagen interpretation of quantum mechanics. So quantum mechanics doesn't tell you what will happen. It tells you the odds of different outcomes. Nature isn't deterministic at the quantum level, it's fundamentally probabilistic. Einstein famously objected to this, saying God does not play dice, but Born's interpretation has withstood nearly a century of experimental tests. So this led to a big question. If quantum mechanics is fundamentally about probabilities, what does this mean for what we can actually know about reality? But that's for the next and last episode. So follow along for more and stay nerdy.